All right, let's talk about subatomic particles. And what I mean by that is we're going inside the atom. And I have all of these crazy pictures up here for a reason that I'll explain. But first, let's review the learning target number 6 in Unit 2. I can identify an atom's correct number of protons, electrons, and neutrons if given the element's name and a periodic table. I can also describe the location, charges, and relative mass of subatomic particles within an atom. All right, let's get going. Heads up, for our next synchronous class, please gather some small objects. You need 3 different types or colors of an object, if possible, and 10 of each type or color. So for example, let's say you randomly had a bunch of M&Ms or Skittles or something along those lines at home. You could have 10 red Skittles, 10 yellow Skittles, and 10 purple Skittles, and that would work great. Maybe you don't have Skittles. You could have 10 coffee beans, 10 buttons, and 10 pennies. So on this first page here, I just put some different ideas, a lot of food-related things. But if you have arts and crafts around the house, you can probably find something that will work, because we'll be processing by building atoms. All right, so when you look at the periodic table, you've probably noticed that there are all of these numbers, and you may have talked about them in middle school at some point, but it'll be great to have a refresher and dive in a little deeper. So the most important number, the number that's at the top, is the atomic number. So you'll notice as you go from left to right on the periodic table, it's sort of like reading a book, and the numbers just keep getting bigger and bigger. So the atoms are arranged by the number of protons. So this is sodium, and it has 11 protons. Also, if this sodium atom is neutral, it has 11 electrons as well. And so we'll talk about ions later, but those are atoms that have gained or lost electrons. Next, you've probably noticed this decimal number, and different periodic tables will have a different number of decimal places after. So we'll try to be consistent on the one that we're using, but if you're Googling and you write down a different one, that's not a big deal at all. But we should not round them when we're using average atomic masses. So I'll discuss that more later. We will be rounding these to the nearest whole number for a different purpose. So the average atomic mass is the average mass of all of the sodium atoms on the planet. So it turns out that not every single atom of an element is completely identical. Just like if you had twins, they're not, even if they're identical twins, they're still not exactly the same. Okay, they might have different personalities, they might have different birthmarks. It's the same thing with atoms. Some atoms have an extra number of neutrons or fewer neutrons, and so that changes the overall mass. Those are called isotopes, and we talk about those coming up. Finally, we often round the average atomic mass to the nearest whole number because that tells us which version of a sodium atom is the most popular. So since the average is 22.99, this rounds to 23. That's an important number because it tells us the number of protons plus neutrons, and we know that there are 11 protons. So that means we can do 23 minus 11, and that gives us the number of neutrons. So we're going to practice this, so hang on tight. All right, let's talk about properties of subatomic particles before we get into some examples. I want to introduce a new unit, which is AMU, atomic mass unit. So because atoms are so small, and because carbon is a very popular element essential to life, a scientist said, all right, let's say that we have this unit that is equal to 1/12 of the mass of a carbon-12 atom. Carbon has 6 protons, and 6 neutrons in this case. So that means that 1/12 would be equal to 1 AMU. And so protons and neutrons each have an atomic mass unit of 1. So talking about the different subatomic particles, we've got protons, which we just said have a mass of 1. And we've got neutrons, which have a mass of 1. And electrons have a very, very small AMU in comparison. No, you do not need to memorize this number. Okay, it's just showing you it's like about 1/2000th of the size. So imagine Newport has close to 2,000 students. Just one of those students would represent the total of how much mass an electron contributes to an atom. Let's talk about charges. Protons are positive, so P and P. Neutrons just sound like neutral, and that means they have no charge, and electrons have a negative charge. Where are these subatomic particles? Protons and neutrons are in the nucleus, and electrons are outside the nucleus. What's their job? Protons tell you the identity of an element. Because protons have a positive charge in the nucleus, they all repel one another. So they need neutrons to supply mass in order to hold the nucleus together. So they're sort of like the glue that keeps the nucleus from splitting apart. And electrons we get into later, they determine how reactive an atom is. So the number of electrons says a lot about how they'll bond with other atoms. All right, let's talk through an example to see if we can make sense of how to determine the number of protons, electrons, and neutrons if you've got a periodic table and you know the name of the element. So aluminum, the symbol would be Al, atomic number 13. It would have 13 protons since it's number 13. It would also have 13 electrons. Its average atomic mass is the number at the bottom, 26.982. The most popular mass number would be 27. And so the neutrons, we have to do some math. We have to do 27, which is protons plus neutrons, and subtract the number of protons, which is 13. So 27 minus 13 is 14. I want you to pause the video here and try to record the entire next row based on this information here. So we're talking about boron because it's got 5 electrons in its neutral form. And then see if you can fill out the rest on your own. Okay. Here are the answers. See if you did that second column correctly. It should have been boron, element B, atomic number 5, number of protons 5, number of electrons 5, average atomic mass 10.81, which rounds to the nearest whole number would be 11. And then to get neutrons, we always do mass number minus the number of protons. So 11 minus 5 is 6. So what type of atom is this? Pause the video, look at a periodic table, and see if you can figure out which atom this is. If you said lithium, you're correct. It's got 1, 2, 3 electrons, which means that the red spheres must be the positive protons, because the reason the atom is neutral is because 3 positives and 3 negatives cancel out. And that means that the blue spheres are the neutrons. And lithium square, the average atomic mass is like 6.94. which means it rounds to 7. So 7 minus 3 protons in the middle means 4 neutrons. I'll leave you with a fun fact. It's very mind-blowing. If you removed all the empty space from the atoms that make up all the humans on the planet, and this was back a stat from when there were 6 billion of us, but you could fit all 6 billion humans inside a single apple. This astonishing discovery that atoms are mostly empty space was actually made by a scientist named Ernest Rutherford back in 1909. So very crazy to think about. So if you removed all the empty space from your body, you would be smaller than a single grain of sand. So sorry to break it to you, but you're made of mostly empty space. All right, and that is it.